hello, who are you? My name is Anna Benzel, and welcome back to my channel. Welcome back after a brief commercial break. We are going to go ahead and jump into a Python solution for LeetCode question number 4, the median of two sorted arrays. So I did do this. It took way longer than it needed to, but I was actually really pleased with the solution I had for this, which was here. Oh, not a note. Here we go. So it beat 78% of people who use Python or wrote this in Python in runtime, and also beat 91 of them in memory. So I actually am very pleased to give this solution. Would I like to find a thinner solution, one that's a little less wordy? Sure. But this did okay, and it passes the smell test, if you will. So let's go ahead and jump into this question, shall we? So the question is, given two sorted arrays, nums1 and nums2, of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be 0 log m plus n. So they give you these examples or test cases, and then they gave you the constraints down here. This is how this code was started when you set it to the default. Excuse me, I am drinking Costco signature sparkling water, and it's kind of coming up a little bit, kind of gross. So let's go ahead and jump into this here. So I started off with trying to say that if the length of nums1 is greater than the length of nums2, then the code swaps nums1 and nums2. This basically ensures that nums1 is the shorter array and simplifies the algorithm. That was the whole point of this. And to start with this would mean that we eliminated like 50% of the work right off the bat. So now we're going to get into the meat and potatoes of this because I'm actually excited. So here, m and n store the lengths of nums1 and nums2 respectively. Left and right are pointers used in this binary search. If you watched the last video, you understand how I kind of use pointers for that. The total length is the combined length of both arrays, and the median is initialized to 0 and will store the calculated median value. How cool. So let's get into this little loop. We started this little loop so that while the while loop iterates as long as the left pointer is less than or equal to the right pointer. And this is the quintessential binary search approach. It just makes me so happy when I can like use stuff from my schooling and like bring it into the light. So for this area here, this kind of partitions through here, this in each iteration, the two arrays are partitioned into two parts, okay? Nums1, partition 1, nums1, partition, nums1, partition 1, and nums2, partition 2, nums2, partition 2. So you see that twice. The max left variables store the maximum value here on each on the left side of each partition. So if you think nums1 partition 1, think of that partition for nums1 and 2. So it's like partition 1 and partition 1, but that makes a whole of nums1. And then again for nums2 and nums2. So the max left variable, I want to just make sure I'm clear on this. The max left variable stores the maximum value on the left side of each partition. So I hope that makes sense. I should probably, I wish I could whiteboard this out, but that's it. And then on the min right variables, it stores the minimum value on the right side of each partition. So William Shakespeare's apple cleft in two, think of it like that. If you guys are Shakespeare fans at all, maybe you're not, maybe you are. But depending on the max left 1, min right 2, max left 2, min right 1, the algorithm adjusts the partition pointers accordingly. So the conditions check whether the medians of the combined partitions satisfy the requirements here for calculating the overall median. So we end by returning the calculated median. So we basically in this code just did a binary search approach to find the median of two sorted arrays, and by literally partitioning the arrays and comparing their median values. That is it. It was a little wordier than I needed it to be. I've seen some other people's solutions for this, and they're a little bit more streamlined. Would love to do a little bit more streamlined one, but I think overall this was a really satisfying solution for me to do. I hope you guys learned something from it. I will leave the GitHub repo that has this solution and all of the other solutions I've done in the description of the video. Feel free to fork and clone, right? You can do whatever you want, learn something, make it better, make it worse, just have fun. That's what this is, and improve upon a skill, learn a new skill. And again, if you have any suggestions, you guys are more than welcome to contribute at all to these videos or the GitHub. Anything goes. So thank you guys so much for watching, and I will see you in the next video. Goodbye.